natural log square root of 81 minus 1 over natural log of 625. I get that lonely feeling again.
How?
Mathy. So far, so good.
Yeah.
Oh no, I made a mistake. Here's what I did. Number 1, I forgot my squaring in the second term. Number 2, you guys, this is 100% wrong, but it was truly my mistake. I made this mistake. Watch. In my head, I said 2 squares equal to 4. It's not really true, is it? 2 is really the square of. What do you square to get 2?
It's root 2.
Yeah, just root 2. I really did make that blunder. Now, it doesn't look very pretty, does it? So my mistake truly was.
So in this situation, would it just be better to leave it like -1/2 times?
Oh yeah, I just
Quantity.
being silly. I'm just
All right.
saying, remember all your properties and logarithms, even though I can't square myself.
Okay.
See guys, yeah, sir?
When you take the -1/2 inside the parentheses, would it change the negative into positive?
You know, I didn't even deal with it. In a sense, I just said, if the first term's gonna have a negative coefficient, I just threw it at the end. I just switched the terms in terms of order. But you can look at it any way you want. Either way is fine. Do you guys think I could finish with just one last example? So one last example. Just guys, take a peek at it for a minute. Any ideas? Any suggestions?
Identity.
Which one? All right, I'll give
I
you-
remember from chapter 7, but it's not.
How about the Pythagorean identity?
It's a 1 plus sine of 2 theta, or
What about this one?
that one. It's just gonna. It's
Yeah, you
gonna
guys, it's
present
just
the
going to
same
rewrite
problem.
everything in terms of sines instead of cosines. I still got one of my basic trig functions squared. I didn't do anything wrong. I just don't.
Isn't there like a 1 minus cosine of 2 theta over 2, or is it 1 plus cosine of 2 theta over 2?
Is plus.
Plus,
Yeah, where'd you get that?
from going through the book.
No, it's just in trigonometry. Do you guys remember this?
Yeah, it's the one they
recall.
didn't give us in trigonometry, though.
What's that?
I didn't get that in trigonometry. It's not on my trig notes.
You're kidding, really?
Yeah, he gave us other ones.
What about this? Do you remember that the cosine of 2x with your double angle identity for the cosine
Yes.
function can be represented this way?
Yeah.
All right, I'm getting too sloppy. Hold on. Oh, but you had another version that said this. Oh, but you had another third version that said this. You guys be honest with me. Is that okay or is that too fast? I know I'm not there yet.
Yeah.
But you guys take that last version and isolate the cosine of x by number 1, adding 1 to both sides. Number 2, dividing both sides by 2. Doesn't that tell me that another name for cosine squared of x is just simply that fraction? I sometimes in mathematics refer to this as a technique of reduction of order. For those of you going beyond this course, that phrase reduction of order becomes fundamentally important. It's a gimmick, or not a gimmick, it's not even a trick. Once you see it once, it's no longer a trick, it's a technique. It's a technique moves along. Now I've got another name for cosine of x, cosine squared of x, which is this. And I think picking this up and substituting back in the integrand's position is going to make my life a piece of cake. I think that gives me the integral of my 1 plus cosine of 2x over 2, and I'm integrating with respect to x. That gives me the integral of 1/2 dx plus 1/2 times the integral of the cosine of 2x with respect to dx. Now help me with the last term. With that last term, how do you integrate the cosine of 2x?
It's just
It's just,
sine of 2x over 2.
where'd you get that?
Well, it's just a chain rule.
Yeah, I agree. You know, technically speaking, you are undoing the chain rule.
Yeah.
So technically speaking, I think you were in your head committing to a U sub. Now, personally, I do the same thing. I don't write it out. But let me write it out. I'm in front of the entire class. We're all coming from different places. If I were to come in and simplify the input of my cosine function to 2x by giving it this nicer name, then the relationship between du and dx is that du is twice dx. And I think that tells me that when I anti-differentiate the second fraction, excuse me, the second term, doesn't it give me positive? Is that a 1/4? The integral of the cosine of x. Excuse me, I meant to say cosine of u, with respect to u.
Yep.
That being the case, we can now anti-differentiate. Let's walk backwards. Is that positive 1/4 sine of u? Is that a positive 1/2 u? What do you think? I put you to sleep, now you're too tired.
The first term should be no.
Yeah, I think I'm way
Yeah.
off. Because I think that those are two completely separate intervals. The first one I wrote in terms of x, the second one I wrote in terms of u. I've got to be consistent with that variable. Remember, this is the variable to which I pledge my allegiance. So, I guess I've got a 1/2 x. Am I done?
You need a sub.
No, I need the back substitute. Let's again put our answer in terms of one variable, specifically in this case my x's, and that leaves me finally with the 1/2 x plus my 1/4 sine of, was it 2x? Let's see. So do you guys think maybe this collection of, what was that, 9 examples might be enough just to set you guys off, get some practice? Almost everybody in this room, I think something like all of us, but maybe 5, said you've seen substitution technique before. For you, hopefully then this is a nice, clean, easy first day, and that I'm simply doing. Sir?
I was just wondering, is the reason why you wouldn't substitute in the first portion of that is just because it would just complicate things? Is that-
Well, let's say it this way. What could I substitute in here? I mean, if I allowed cosine of x to be u, is derivative sine of x, well, negative sine of x, but I don't see that anywhere in the transposition. So when I come into that u sub, I want to do it in such a way that maybe neglecting numerical coefficient, the derivative of u is in the integrand's position as a factor. And so I think letting u be cosine of x means its derivative sine of x has to be somewhere in the integrand's position.
Well, I was talking about the half dx, like when you put
Oh, sir, do you mean from here to here?
in, yeah.
Gotcha. Let's check it. I think with my blue pen, this particular statement says that dx might be considered or could be interpreted as 1/2 u. So I took this dx right here, and I replaced it with 1/2 du. I just pulled the 1/2 out. 1/2 times the other 1/2 gave me the 1/4. I mean, that's all I did with the 1/2 business. Well, you guys, let me show you how you can get some practice. You can tell it's the first day I've already lost my voice. Hey, you guys to dive in to section 5.5. Take a peek. F9. Just the opposite supplies. So can you guys hold on for just 1 second? Glasses. So we have 2 people who shares. Like I said, you guys, if it's okay with you, can we stop? But in stopping, as long as you're registered for the course, you're free to go. For everybody else, can you stay for a few minutes to talk? Actually, not a few minutes, I'm going to And Linda Dever, can you stay too as well, please? Sure.
So, this covers this covers, substitution.
Yeah, so if you're using a different book, just go into whatever section got that title, substitution technique.